Hello guys, welcome to my channel. In this class, we will start with the instrumentation of the mass spectroscopy, different type of ionization techniques. We will discuss and we will discuss the Koch-Pole and time of flight analyzer. We will complete almost 50% of the syllabus in this 50 to 60% of the syllabus in this video. This video will be a little bit lengthier than the usual. I will try to complete it faster. I will not take much time. Okay, this is the instrumentation you have to draw for your if they ask, you have to draw this instrumentation diagram. I'll explain the instrumentation diagram. See, contains sample ingestion port. See, this is the sample ingestion port. In it's like it's connected to a larger reservoir where small entrance is opened, where the sample is pumped into the mass spectroscopy. This is all taking place in an vacuum state. Okay, first remember it also takes place in vacuum state where gravity does not influences. Okay, then it the sample vaporizes by this filament. Okay, it vaporizes. Okay, by this using this filament the sample is converted into the vaporous state and electron beam. This is the ionization instrument. Okay, by different ionization techniques we vaporize, we strike the high energy electron beam through the sample where it converts into the positive ion fragmentation. It converts into many fragmentation, but we only take positive ion fragmentation, positive ions. Okay, positive ions. Okay, next this is the sample molecules. See, we are getting the sample molecules. Then uh, accelerated ion beam, we will use different types. It contains three slits. Okay, three slits where by using the different voltage. Okay, using the positive magnetic field, positive magnetic field, as we only take the positive right here. uh, Positive electrons are generated. We will also use the positive magnetic field due to the repulsive nature of the positive and positive. By this the electrons we will accelerate. Okay, accelerate into the magnetic field. Okay, the beams are like accelerated, and this diverts into the detectors where the analyzers are placed here. Okay, it arranges according to the mass to charge ratios. Okay, here lighter molecules will be on the top and heavier molecules will be on the bottom. They will arrange according to the mass and charge is all everything is similar. Okay, according to the mass. Okay, this is the detector. We use a photo multiplier. Okay, Friday's cup, etc. as the detectors. This is the basic instrumentation. I hope you are understanding it. Next, see, this is the parts of the instrumentation: sample inlet, ionization source, ionization, different methods we are using: acceleration, deflection, and detection. Okay, before detection we use mass analyzers to sort them according to their masses. Okay, we'll discuss everything in detail by one. We'll start with the sample inlet. See, the sample stored in a large reservoir from which a molecule reaches ionization chamber at low pressure in steady stream by a pinhole called molecular leak. See, I have said you right. Here it contains a molecular leak. It contains a pinhole where the sample is uh, sprayed uniformly in the analyzer. Okay, this is a sample inlet. Next, ionization source. Ionization source, of course, depends upon the ionization method. If it is based upon the ionization method, different sources are used. Uh, Based upon the ionization method, okay, what type of ionization takes place? We have many ionization methods. We have 8 ionization methods based upon the ionization method. Example, if electron impact or chemical field or fab. Based upon this ionization methods, we will use different ionization source. Okay, we will discuss some ionization source and we will detailedly discuss in other ionization sources. Okay, first ionization source in electron analyzer is dioplasmatron, argon plus, O2 plus or C minus. This is element, it is a source where these are used to bombard with the sample. Next, see, ion source with surface ionization. Ion source of surface ionization is Cs plus ion source. Ionization of field is gallium plus liquid source. This is like not important. You have to just mention that ionization source is depend upon the ionization method. That's it. In that we have two types of ionization techniques. Okay, first is hard ionization, soft ionization. This is very important. Based upon this, we get the data. See, what is hard ionization? Larger molecules are extremely fragmented then analyzed. Larger molecules are not extremely fragmented. Okay, the basic difference is, see, larger fragmentation, larger data. Okay, larger data, larger we will get to analyze. Okay, analyze or takes place in the gaseous phase, analyze in the any phase. It is soft. Okay, larger data is produced, lesser data is produced. Example, if you see, take an ice molecule, any ice cube. If we break small piece, we will get only some water. Okay, if we break into many pieces, okay, I mean, like, if we make like 90% of the ice is broke, we will get 90% of the data. If so in soft ionization, we will not break like 90% or 80%. We'll break 30 to 40% of the molecule. We get less data. If the fragmentation or the breaking is higher, if fragmentation or the breaking is higher, then uh, we will get higher data. Larger data is produced, less data is produced. That's the basic difference between soft and hard ionization. If examiner want to make a tough question paper, he may ask different type of ionization techniques. Okay, different types of ionization techniques in either soft ionization or hard ionization. Okay, we will discuss these ionization methods. This is the ionization methods and this is the techniques. Okay, hard ionization, soft ionization. Ionization methods: electron impact ionization, chemical ionization, field ionization, fab, and MALDI, ASCI, ESI, APPI. These are like 8 different types. We will go through one by one each. These are very easy. I'll explain you in a very understandable language. See, this is the electron impact ionization. Okay, uh, just understand the diagram and you can write on your own. Hmm? Huh. See, understand the diagram. See, it contains an electrode of 70 eV. Okay, and this is the analyte. It is passed in the gaseous phase. This is present in the gaseous phase, is passed through the gaseous phase, and it is sent to the mass analyzer. Here the interaction between the electrodes and the analyte takes place. The high energy electrodes are collided or bombarded with the analyte, and where they take one electrode from out of the molecule, and M plus ions are formed. Okay, these are sent to the mass analyzer. This is the basic principle of the electron impact ionization. See, if you read this, you will easily understand. A beam of electrons passes through a gaseous phase sample and collides with neutral analyte molecule to release or produce a positively charged ions or fragment ions. Okay, I hope you are understanding. You just read it. A beam of electrons passes through a sample gaseous phase sample and collides with a neutral analyte molecule to release or produce positive charged ions or fragment ions. Okay, generally electrons with energies of 70 eV are used for fragment ions. Okay, 70 eV energy electrons are used. Okay, if you use higher energy, the fragmentation takes many electrons from the sample. We need only one electron to emerge. We use only 70. Okay, positive ions are collected in a focusing plates and are passed to the mass analyzer. Okay, this is the basic principle involved in electron impact ionization, and it is only used for known compounds. Okay, if we know the compound and have to know the mass number, then we use this method. Okay, next, chemical ionization. Vaporized sample reacts with pre-ionized reagent. gas via proton transfer or charge exchange or electron capture or uh, addict formation. Okay, these are different types of process takes place in chemical ionization. We will study in detail. See, this is the chemical ionization method. Here the chemical ionization reagents are methane, isobutane, hydrogen or methanol. These are the different types of techniques used. Here chemical ionization we already discussed, right? In that example, chemical ionization is a soft ionization, means it produces little fragments. Okay, see, first example, take this as an reagent. Okay, which reacts with high energy electrons. When methane reacts with high energy electrons, there are formation of many fragments, many unstable fragments. Example, CH4, CH4 plus, CH3 plus, CH2 plus. Okay, these are unstable and react with another molecule of methane, okay, to form very highly unstable molecules. These are very highly unstable molecules. They are ready to react with the analyte or the molecule sample. Okay, CH4 plus CH3 gives rise to CH plus CH5 plus and C minus CH3. Okay, and CH3 plus gives plus methane gives rise to C2H5 plus and H2. Okay, these two molecules are highly reactive. Okay, they are ready to react. When they react with the sample molecule MH, they replace they take the electrons from the sample to form the positive charges. See, if with this react with the sample, mh2 plus, mh2 plus and m plus. Okay, here here the same reagent we are using, but the number of hydrogens is different. Okay, that's the this way we will convert the positive ions. Okay, it is mainly used for molecular weight of the to the molecular weight of compound we used. Okay, next, field deposition. Okay, this is very simple. There is no like particular diagram, but you just understand the principle behind it. Stable molecules, ions, are obtained from the sample of low volatility, which is placed on the anode of a pair of electrodes. Okay, between which there is an intense electric field. See, the sample is placed between the electrodes, pair of electrodes. Between them it is an intense electric field is present. Deposition occurs. Molecules and quasi molecules, ions, are produced. Quasi molecules means combined molecules and molecular clusters. Example, you know the clusters, right? Combination of like one or two molecules or three or more four molecules combined to one another, it is called as clusters. Combined molecules are formed and molecular clusters are produced with insufficient internal energy for extensive fragmentation. Okay, synthetic polymers with molecular weight in order of 10,000 daltons has been analyzed, but this field deposition is not much used. It is only used for molecular polymers with molecular weight of more than 10,000 daltons. Okay, here it is also soft ionization method, so that fragmentation is not uh, produces large data, only small data is produced through this field deposition. Next, the important one, fab. This is very important. This is very important for your exam point of view. Okay, you have to like this and fab and the MALD. These are both similar, but there is a small change between these two. Okay, you have to read these two. That's more. If you read more than 5, it's more than enough for your exam point of view, because they won't ask particular ionization method. They will ask enlist and explain the ionization technique. Okay, polar molecules such as peptides with molecular weight up to 10,000 daltons can be analyzed by a soft ionization technique called FAB. Okay, FAB means fast atomic bombardment. employs fast moving neutral inert gases atoms like argon and xenon to analyze the large molecule. Here the ion source is neutral inert gases, okay, fast moving neutral inert gases, gas atoms, okay, neon and argon. Sample is employed in glycerol and sprayed in a thin layer of metal probe. Here the sample is sprayed on the probe by dissolving in glycerol, okay. The probe is then inserted into the mass spectrometer, and a beam of uh, fast moving atoms probe the surface using an analysis of the sorry guys, I have made mistake. Probe is see, just read one more time. Probe is inserted into the mass spectrometer, and a beam of fast moving atoms which bombards with probe, the bombard with the probe of the surface, okay, use just for analyzing the surfactants and proteins. See, yeah, I'll explain the sentence. I think so I've made a grammatical mistake. The probe is inserted into the mass spectrometer, and a beam of fast moving atoms falls on the uh, probe surface, and this method is used to analyze the surfactants and proteins, okay. I will explain the diagram. You will understand it very clearly. For large and thermally unstable molecules, fab is carried out, okay. If the molecules are large and thermally unstable, okay, heat unstable, then fab is used. Works well in room temperature and simple, highly sensitive. Sample can be recovered. The sample can be also recovered. See, this is the instrumentation of the fab. It contains the sample probe. This is the probe, okay. This is the coated layer, okay, where the sample is dissolved in the glycerin and sprayed on the probe, and this is the fast particle beam of atoms, okay. This particle beam of electron is angled on the probe, okay, is angled on the probe. Here when these inert atoms react with the probe, falls on the probe, they excite the molecules, okay, they excite the molecules and makes it to react with them, and they take up the electrons. See here, xenon plus electron gives rise to xenon plus plus, which is very highly unreactive. It reacts with the sample molecule and takes electrons, and plus ions are formed, positive ions are formed, okay. By this way we will get the positive ions, and these are focused into the uh, focusing lenses, okay. This is the basic principle of fast atomic bombardment. Hope you are understanding. Next, the fifth one, uh, matrix associated laser deposition technique. See, the fab, the both, just see, just bring it back, huh. Both the diagrams are quite similar, but we are replacing the laser. This is fast particles beam of atoms, right? This is fast particles beam of particles. Here we are using laser beam. That's the basic difference between these two both, but there are quite similar. Everything is instrumentation, everything process, everything is similar, okay. Here matrix associated laser, okay, this is the basic difference, okay. You are using an laser instead of the atoms, inert atoms. You are using the laser to excite the molecule. Unlight or matrix pad, this is the unlight, and the matrix pod, okay. Unless and matrix pod is combined in it. Sample plate, uh, here the fast moving laser, or sorry, the laser is angled into the matrix, and there fragmentation, first ionization takes place and then fragmentation takes place, okay. We'll see with the theory, then I will explain the diagram. Matrix disperses large amount of energy observed by the laser. Okay, see, in the matrix, like it absorbs the large amount of energy by the laser, minimizes fragmentation of the molecule, permits analysis of molecular weight over 10,000 daltons. Okay, here if the molecular weight is over 10,000 also, it can be analyzed larger biomolecules. Okay, must be stable in vacuum and not react chemically. Um, must absorb strong at laser. Okay, it's wavelength. Okay, the matrix, it should absorb strongly and make the analyte to absorb it. Okay, see, IR region, we use urea alcohol or carboxylic acid. For UV region we use 3 hydroxy picolinic acid, or we use 5 chlorosalicylic acid. Okay, these are both the regions, I mean UV regions. Okay, the it comes to the diagram, we use the matrix. In matrix we store the analyte. Okay, where the laser excites the matrix, where it transfers the energy to the analyte and it breaks and it forms matrix ions and analyte ions, where analyte ions are passed into the analyzer by using the focusing lenses. This way we will analyze, ionize the sample. Okay, next.